Okay. In today's lab, what we are trying to go into is spam classification. We'll be having a data set on which we'll be performing spam classification. Okay, so your data set is containing spam as well as non-spam data, and on this data, on this textual data, you are supposed to perform classification on using two classifiers that we'll be using is naive Bayes classifier, and the another classifier that we'll be utilizing is decision tree classifier. So you have already studied about these two classifiers before, right? So in order to perform the classification, we have to go through some of the pre-processing steps of the data, right? So do you recall the textual pre-processing that will be required in this case? Any of the pre-processing steps do you recall? We had discussed this in the lab too, right? Yes, tokenization is one of the steps that we can go through. Well, in this case, we might not require tokenization. We might not go through tokenization, but these are some of the steps that we have to do in the case of textual classification, that is lemmatization, tokenization, right? And removing stop words and punctuation. These are things are there, right? So one of the ways in order to deal with the textual data, would be to convert this textual data into numerical form. Okay, so if you know that machine learning will actually deal with numerical form of data. Yes, IDF. That is what I'm going to talk about. That is one of the methods. So before that, I'll be talking about one more method, that is bag of words, that I'll be discussing. Just a brief, I'll be in the case of, yes, right, make them as columns of the data set. Yes, I'm coming to that. Just so what will be happening is we'll be converting these words. So we have how many unique words we have in this case? I guess we have good, one is movie, slow, but, okay, not so entertaining. And also, first thing that we'll be doing is we will be removing stop words. So you have to already define what are the stop words that you might be considering for removal. For example, but, okay, not, so these are some of the stop words that are present in your data set. So you have to remove them first. So some of the unique words that you'll be identifying is good, movie, slow, entertaining. Okay, these are the 4 unique words that you'll be identifying. Later on, you'll be representing these sentences S1, S2, and S3 in vector form. How will be representing? So as Keval also mentioned, that you will be converting this unique words into columns. So example, good, movie, and entertaining are three unique words that I'm considering for performing the classification. For example, I'm considering these 3 words. So for example, in statement 1, good is present one time, so I'll be mentioning it as 1 here. Rest of the movie is also present one time, so here also I'll be adding 1. Rest I'll be adding as 0, right? Similarly for statement 2, that is, okay, one more we missed, I think, slow. Just add a slow here. So here there is a slow, but okay is, I guess, yes, that is a bad thing, right. Okay, that is one problem that we might face in this case. You are correct in this particular point. So that is one point that we might consider. So if you recall in the TF-IFD also, that I'll come to. So in TF-IFD also, what we are trying to do is we are trying to minimize the importance of such words instead of removing them totally. Okay, so what we are doing in stop words is we are totally removing the stop words. But in the case of TF-IFD, what we are trying to do is we are trying to minimize the most frequent word and trying to minimize the importance of most frequent words, which are also stop words. There are transition words. Yes. So there is a possibility. Or what you can do is you can define your own stop words. Okay. Instead of, for example, I'm just coming to that point. For example, in this count vectorize, which will be utilizing in order to perform this particular task. Just a minute. Okay. So in that, there is a possibility that already some of the stop words are mentioned. What you may do is you may try to establish your own stop words and remove it from the sentences. Okay. Are you getting the point? Yes, Janet? Okay. So just let me give a brief first of all about bag of words, and then we'll come to TF5D, and then we'll start with the practical, right? So as I mentioned, in the bag of words, what we'll be doing is we'll be creating a bag of it will be creating statement S1, S2, and S3. We'll be converting them into vector form. For example, if the good is present in statement 1, it will be added as 1. How many times it is present? For example, 1, 2, 3, 4, and as many as number of times it is present, that number will be mentioned here, and so on. So for example, S1 will be mentioned as 400, or S2 will be mentioned as 100, and S3 will be presented as 0101. Okay, something like this. In this form of vector, it will be presented. Later, this vector you have to pass into the classification model in order to perform your classification. That is, using naive Bayes classifier you may pass, or you may pass into decision tree classifier, whatever classifier that is present. So this you will be implementing, this particular task you will be implementing, you will be utilizing count vectorize. That is just a minute. Yes, count vectorizer, which is a library that is present in your scikit-learn, which is a function that is present in your scikit-learn library. You have to study this particular count vectorizer, which will help you to convert this statements, all the statements, into vector form, which is one of the way how you can implement the bag of words method to convert your textual data into numerical form. Is this first part clear to everyone? Is this one clear? Okay. Can we use encoding? So you want to use any encoder? Do you know of any encoder, textual encoders, such as like in encoding? How you mean encoding? So you want to use any word encoder that are present in, or you want to perform your own? That is, you want to define your own functions. That is what you are trying to say. Okay, one hot encoding. Oh, sorry. I get it. So one hot encoding method you want to use, but if you see, one hot encoding won't be a good option here. Why it won't be a good option is, if the number is present, it will be added as 1, and if the word is present, it will be added as 1. Rest, if the word is not present, it will be added as 0. Okay, that is one hot encoding method that you are using. So what will be the problem here is, also it is a problem in bag of word as well. More sparse matrix will be created. This is also known as binary term frequency kind of thing, where if the word is present, you will be adding as 1, and if the word is not present, you will be adding as 0. So it is possible. Yes, then the matrix becomes sparse. Yes, that is the problem that we have. That is, sparse matrix will be created. Even in bag of words also, sparse matrix, there is a possibility that sparse matrix will be created, and also there is a problem that the correlation will be very high. If you see, if all the matrix is 1, 0, 0 and something like this, correlation will be very high. So this might not be a good option to try, right? Okay. Huh. Okay, so the next method that we have is TF-IDF, which is term frequency and inverse document frequency. Okay, so anyone having any doubt up to this? So shall we proceed with this one? Okay. So term frequency, you already know what is term frequency? Anyone? What is term frequency? Term frequency is number of times the word appears in the document. Yes or no? number of times the word appears in the document. So for example, if you want to identify the term frequency for was or yes, anything, any word that you want to find, so total number of times this word appears in the document upon total number of words in the document, that is term frequency for you. Then we have inverse document frequency. Anybody recall what is inverse document frequency? First, we have to identify what is document frequency. What is document frequency? The number of documents in which the particular word is present. Okay, number of documents in which the particular word is present, that is document frequency. And then we'll be identifying inverse document frequency, where the total number of words in the document upon the document frequency. Log of this, that is inverse document frequency. Yes or no? Do you recall this? Yes or no? Just let me know whether this is clear or not, this IDF formula. So inverse document frequency is, first we have to identify document frequency, which is number of documents in which a particular word is present. For example, was is a word that you are identifying. So number of documents in which the particular word is present, that is number of documents in which the particular word is present, that is document frequency. Later we'll be identifying inverse document frequency, which will be log of number of words, the total number of documents upon number of documents in which that particular word is present. That is inverse document frequency for you. And one of the problems that we have in the case of bag of word is we are not able to identify what is the importance of a particular word in your statement, right? We are just adding a numerical term. So in this case, you will be having this, so you will be doing this TF IDF, where you'll be multiplying the term frequency of the word and inverse document frequency of the word. So the most frequent word, for example, instead of removing your stop words previously, like is, was and all, you will be directly minimizing the importance of these words in the sentence. So if you see that inverse document frequency of such words, is, was and all, will be very low. So automatically the score will be low for such frequent sentence words, and other than those words, other than those, for example, good or a movie, this kind of words might get good higher importance. Okay, that is the main idea behind the term frequency and inverse document frequency, right? So I hope these 2 points are clear to everyone. Yes or no? Just let me know whether it is clear or not. So we'll be starting with the implementation part now. So just acknowledge whether there is any query with this in this regard. So in this case also we'll be creating vectors. Okay, similar form of vectors will be created in the how it was created in the case of bag of words. Similar to that, here also vectors will be created, and this will be your column term. The words will be in your columns, and here your TF-IFD score will be presented. Okay, that is what will be done. So we can go through one of the implementation with the help of count vectorize. We'll go through count vectorizer implementation. I just want to give an idea that how the matrix will be created, and later what you are supposed to do is for today's task that you are supposed to do is you have to for example I'll be uploading a spam database, the data set I'll be uploading. So what you are supposed to do is you have to perform this in using count vectorizer, which is a bag of word implementation. Okay, you have to perform this using count vectorizer for both naive Bayes as well as decision tree classifier. Okay, for both of this you have to perform using count vectorizer, and later using TF-IDF vectorizer, which is also present in your scikit-learn library. This is also present in your scikit-learn library, and later compare what is the accuracy that you are getting with the help of naive Bayes classifier in this one as well as in the case of count vectorizer. Okay, that is what you are do. And one more thing that you have is in the exercise that you will be given is, in the exercise you are given one statement where you have to try for bigram matching instead of unigram matching. Okay, so there is a attribute that is present in count vectorizer, which is n-gram, something like n-gram match something is present in your count vectorizer, which is how this is interpreted is, for example, at a time you want to create vectors for only one word, then it is unigram matching. But for example, you want to take two or more words at the same time. For example, you want to create, for example, there may be a certain task. Let us say, for maybe there may be tasks such as you want to classify a statement into visual or non-visual. So there is a possibility that two or more words combined can give more higher, can give more insight into the statement instead of taking one word at a time. Are you getting the idea? So instead of unigram, you may try for bigram. That is taking two words at a time. Taking two words at a time means, for example, good movie is a certain kind of good movie. It is a good movie. So at the time you will be taking two words into consideration. That is what you will be doing. So this experiment I am giving to you as in you have to try by yourself and come up with what is the observation that you are getting. For you, instead of unigram, you have to try for bigram matching, and tell me that what are the results. What is the change in the result that you are observing in the case of bigram matching? Is it clear? Are you getting what is the case with bigram matching? Yes or no? Just let me know in the comment section, in the sorry, in the chat box. All right. So just let us go through the implementation once for one of the statement. Then I'll upload the PDF, and then you have to start with the implementation part. And also regarding the regarding today's lab. So after 1 hour, I'll observe that who has what is the progress of so far in your implementation. So be ready with your implementation as well. So keep doing it while in the lab as itself. So just a minute, I'll share the screen. Wait for 2 minutes. I suppose the screen is visible. So just have a look at how we are going to proceed with the task. So for example, what we'll be doing is we'll be importing the count vectorizer from the feature extraction, which is this part is also known as feature extraction from the text, which is present in count vectorizer, and we also have TF-IDF vectorizer present in this particular scikit-learn library, right? So the first task that you are supposed to do is, for example, I have, just for an example purpose, I have created a set of statements here. So in this particular document, I have 5 set of statements, And later on, using the count vectorizer, you have to pass this, you have to perform the fit and transform per function, which we'll be utilizing in order to convert this document into this bag of word form. So for example, in the first statements, so if you see in the first statement, we have two words devastating twice. I have kept it twice. So if you see, after performing fit and transform, this CV, the vector form of this will be created. The vector form of this words will be created. So here is the first statement. The first statement that we have created. So what are the columns? These are the columns. If you use the get feature names function on, if you apply the get feature name function on this particular vector count vectorizer object, then you may observe that then just a minute. Yes, then you may observe that these are the set of columns that are created. These are the columns. Okay, based on these columns, these vectors will be created. So for example, in the first statement, if so, for example, this 19, this word 19 is present, then it will be added as 1. And what is the count of that particular word? So for example, only one time it has appeared, so that's why it will be kept as 1 itself, right? So here devastating has appeared twice, here the count is 2. Okay, so in this way, this vector will be created. Later on, this vector has to be passed into the classifier that you are creating. For example, in this case, you will be creating a multinomial naive Bayes classifier. So we had already discussed in the when we were talking about naive Bayes classifier, that multinomial naive Bayes classifier will be much more helpful in the case of textual classification based task. So you have to utilize multinomial naive Bayes classifier as well as decision tree classifier to perform the implementation of this particular uh, um, uh, lab work. Okay, is it clear that what you are supposed to do? Similarly, with count vectorizer you have created, so you can also create TF IDF classifier here. Just a minute. So we have TF-IDF vectorizer as well, which you can utilize to perform for the TF-IDF. Right now you may start with the today's lab work. What you are supposed to do is, I have already explained that you have to perform this both the task for this count vectorizer as well as TF-IDF vectorizer. And after 30 minutes, that is on 9:30, I'll observe the work of some of the students. So do not leave the meeting. That you are not supposed to leave the meeting just because you are being going to be questioned for the lab work. And I'll also make an observation that who is leaving the meeting. So just make sure that you stay in the meeting and perform the lab task that is given to you, right? So after 30 minutes, I'll be checking what is the progress. And if you have any doubt right now, just let me know. If anybody is facing any difficulty in understanding what you are supposed to do in today's lab work. Okay, so I suppose everyone is clear. Fine, you may ask the doubt by unmuting yourself or in the chat section. Fine. So I'll share with you the file and you may start the work with the today's lab work. Okay. Yes, Keval, I'll upload in a short while. Yes, so Priyank has a question. What is target value means? Okay. In okay, so target value. So target value is actually for this case will be having classification based stars. So the target value will be 0, 1, and yes. So here what will be given? So if you see the input that will be given to the model, into the model that will be given is instead of words, will be providing vectors of the words that will be created using this particular process that is converting to word to numerical form, and will be passing the vector form of the words as well as a target attribute that will be identifying. So in the spam database that will be giving you, there will be target identifier as well as there will be target values, that is 1 0, that is whether the statement is in spam or whether the statement is in non-spam. So that target value as well as the vector that you are creating, you have to pass it into the model for training purpose. Is it clear? I suppose that is the doubt that you have, right? Okay. So I have assigned the lab work for today. Just do take a look and start performing. So I'll take an observation that what is the progress at around 9:40. Okay. And also many of you, around 53 of students, haven't turned in their GitHub repository links yet, which was stated to be uploaded by yesterday. So I'm giving a time till today till today to upload the GitHub repository links, and I'll also inform about the practical evaluation in some time about how we'll performing the evaluation, right? Okay, so upload the GitHub repository links, everyone. Yes, you may try that also. Yes. So there are stop words present in that NLTK library. You may try whatever combination you may want to experiment. You may experiment using this particular task, right? So you may do for NLTK as well. Yes, they are different. So in bag of words, what we are doing is we are directly just creating vectors by how many times they are present. So in bag of words, what will be happening is, for example, if you have a particular statement in which two times devastating is appearing, so we'll be having two as a number of times it is appearing. So it is just a numerical data that will be creating based on the statement that we have. While in TF IDF, which is a frequency and inverse document frequency, there will be it will be actually a different form. So we'll be creating first we'll be identifying the term frequency, that how many times this word is appearing in a particular document, and in document frequency, that how many documents this word is appearing, right? And it is one way you are trying to create. For example, least important word will be having less term frequency, inverse document frequency. More or less frequent word will be having higher term frequency and inverse document frequency. So this is one difference between bag of words and term frequency. And So you have to experiment using both. So you can implement count you to implement the bag of words experiment, you may use count vectorizer. Okay, count vectorizer is a method to implement bag of words. And for TF-IF IDF we have a term frequency inverse document frequency vectorizer. So you have to implement using both. So for the spam dataset that I have provided, you have to try with both of them. Yes, you try to use the spam classification, spam.csv. So spam1.csv we have used in the experiment, I think in the, just for, it is a smaller database, I guess. So you may try, or I think in the lab, in the PDF that I have provided, I might have used that particular spam1.csv. So try with spam.csv dataset that is present with you, right? Okay. Okay, Crystal, uh, did you try to convert this into pandas using pandas? Okay, you have done that? Okay. So which file is it showing error in? Spam? Is it in spam? Okay, all of you are getting this error in spam.csv. Okay, okay. Fine. Just a minute. Let me check and will I'll let you know. Yeah, you may try spam1.csv till that time. So I think maybe some issue is there in spam.csv. Maybe try spam1.csv. It is working, right? So try right now try for spam1.csv. I'll check for the spam file. What is the so love is getting error in both the files, but I guess spam1.csv is fine. So try with that one, right? I'll check for spam file. So I have updated the spam file. I think there were some extra columns present in that file because of which you might be getting that error. So I have uploaded it, re-uploaded it with the name spam 2. So you may try with that particular file as well. Okay. Okay, so far, where have you reached? Anyone would like to share their screen and share their work? How far have you reached? Okay, transforming to vectors. Good. Anyone done with any one of the part? With any one bag of words or this TF, IDF, any one of the part? Is anyone done with any of the part? Okay, spam 2 as well. What is the error that are you facing the same error that we were facing previously? I think when I tried in my particular code, I was not facing the error. That's why. Okay. The same error. Are you facing the same error? Yes. Yes, love. You may share the screen.
Ma'am, I'm facing
Yes.
the same error in spam 2 as well, in spam and spam 1, in all the three files.
Okay. In all the
Yeah,
three files, are
Unicode.
you facing?
Yes, ma'am.
Okay. Did you try to just go through, just open the file once? Maybe spam 2. Could you open this file? I just want to
Ma'am,
see.
here it is.
Okay. All right. Go through the code. Just go to the code part. So others are done with this error, right? Are others facing this error? Anybody else who's facing the same error? No. Okay. Okay. Yes. Go to the code part just once. Yes. Yes. Hello, love.
Ma'am,
Yes.
ma'am, I'm just right now uploading I mean, I'm just accessing the data. That only I'm facing the error. This much only I've written.
Okay. Yes. Yes. Right. Just I wanted to see. Okay. Uh, uh, Maybe can you try re-uploading this particular file in just the content part, just instead of uploading into the drive. Just I just want to check whether it is maybe having some other issue or not.
Ma'am, I've
Just
tried like
upload it
this.
in the spam. Okay, have you uploaded in this, the
Yes, ma'am, I have
content, just the
uploaded it.
content?
Ma'am, here it is.
Okay, so you are facing here
Then also
also.
I'm
Okay,
facing the same error.
okay, position 10. Fine. Wait for some time. I'll check and we'll let you know. Okay.
Yeah,
No
okay,
issues.
thank you.
What about others? Has anyone done with the any one of the part? TF, ITF, or the count vectorize? Okay, shell. Okay, this is the error in V2 sentences are there. Then okay, 1 minute. So shell, you are getting this error for TensorFlow in the output screen after performing which process? Okay, just after reading the CSV file. Fine, no issues. I'll just check and will let you know. And regarding this particular, so are you trying to read this particular CSV file using the Pandas library? Okay, fine. So this is some GPU error that you are getting. Fine, I'll check and will let you know. And okay, you are doing this in PyCharm. Fine. Maybe try in Google Colab whether you are getting this problem or not. Just try in Google Colab once, and later I'll check and we'll let you know what is the issue with the PyCharm, right? Try it in Google Colab as of now. Okay. It also gets the same error, is it? Okay. From tokenizer sequence. Uh, okay. No, no. It also gets the same error. Okay, the Keras. Okay, fine. Maybe you have not do not have the package present in your PyCharm. So try to install it, and also try for installing the TensorFlow uh, in the Google Colabs as well, and let me know if you are facing this error again, right? Okay. And Priyank, so in the data set, the column V2 sentences, so in this particular data set, V1 column that is present, so in the first column, V1 column that is present with you, that is the classification column that you have. Okay, that is spam or non-spam. So that is the classification column. That is the column for 1 and 0. So what you need to do, and V2 column is your textual data. So first what you need to do is, you divide your data set into training and testing. Okay, first you divide your data set into training and testing. So you'll be having your X columns and Y columns and testing X columns and Y columns with you, right? That is done. After performing that, what you have to do is you have to define this count vectorize object. So in this particular file also, what I have done is the one that I had shared in the lab practical when I was explaining, you define a count vectorizer. So after defining the count vectorizer, you have to perform the convert the text into words into numerical form. Later, the numerical form text that you have created, for example, on the train X data set that you will be creating. So you will be using train test split to split your data set into training and testing. So the train X on which you will be converting your textual data into numerical form, that you have to pass into the naive Bayes classifier. That is your training and testing X and Y that will be passing. If you recall, we had defined the multinomial naive Bayes classifier, and then we were performing it on the training and testing data set. Are you getting what you are supposed to do? Is it clear now? Is the idea getting clear? Okay, fine. Proceed with this particular part now, and I'll see for the errors. So has anybody done? Anybody else tried for this? So I'll randomly ask for any number. Should I go for any random numbers and check that what is the get feature? It will give an error. Count vectorized object has no. Okay, see what you might be trying to do is just a minute, Keval. I'll see. Prince, you might be doing is you will be might be calling this get feature names out on a wrong object. Maybe you are trying to call this on a uh, get features name out. Are you calling the right function? Yes, I guess. Yes, so maybe you are calling on the wrong object, I guess. So after performing the count vectorizer, you have to call on CV, the vectorizer that you have created. Count feature names. Sorry, get feature names is the function that you have to use. Out is, I guess, is not a function. Is it a function? Yes. Yes. Yes, it is get features names. Right? So try for get feature names instead of the out. Okay? Yes. Okay. Yes, Keval, you may try to remove, but in the count vectorizer, you are already mentioning a term. If you see, there is an attribute. So Keval, there is an attribute stop words English, which automatically will remove the stop words that are present in your textual data set. Or in order to remove some punctuation marks, you may try to remove the punctuation marks that are present, and may try to do this. Pre-processing step is expected, so you may try to remove the punctuation marks and do the following task. Okay, is it clear? Yes, yes. We are using count vectorizer. We are getting vectors, which is in bag of words. Yes, which is bag of words. So I try to explain. No, no need to remove numbers. You may keep the numbers. Yes. Okay, so that is what it is trying to do. Count vectorizer is creating vectors of the particular sentence. So if S1 contains particular, it will create a vocabulary from the all the documents that you are passing, from the n number of statements that you are passing. It will create a vocabulary. That vocabulary will be your columns, and later on that column, based on the columns, that vectors will be formed. Some numeric data is also coming. Is it because of yes, right, it is because of the numerics that are present in your v2 column. So whatever unique terms, unique words that it is finding out, that all will be included in your feature names. That is your vocabulary in short. Okay, is it clear? Yes, Harsh, is it clear? Okay, fine, proceed with the task. So love facing some issue with the spam too. Are you able to? Have you been able to sort out that? Or okay, how did you solve it? So what was the issue? Okay. Okay, so that solved the issue. Okay, good. So I tried to solving this particular problem, but maybe it was okay. Right now, so it was not. I was looking into it. Okay, fine. Anyhow, you have solved it. So good. So Keval, yes, you have a problem with unigram and bigram. Yes. As of now, you may try with unigram, and later on, as a part of this experiment, you have to try with bigram as well. So you have to use that ngram. There is an attribute called ngram in the count vectorizer, where you need to make changes. Okay. No, no. Only yes. Only try with bigram. Yes. So first, the first experiments that you have to go through, you have to try with unigram, and later on, you for your understanding, you may try with bigram and check what are the results and make certain comparisons. Right? Yes, that means 2-2. And if you want to include both unigram and bigram, you may go with 1-2. Yes, and just 2-2, just bigram you want to do is 2-2. Yes, yes, right. Only bigram. Yes, Priyank. Share the screen.
Yes, ma'am. Screen is visible.
Yes, yes, it is visible.
Yes,
Okay.
ma'am. So here, when I try to convert into vectors and print them, so in every vector I am getting value 0, not 1.
Okay. Maybe right now you are getting. Did you try the multinomial naive Bayes on this one? Did you
No,
try?
ma'am, but I am not getting vector, so how can I try?
No, maybe what is the possibility? There is a possibility that maybe it is right now, since the number of vocabulary, if you will check the vocabulary, there are around 1000. So in this one, in the smaller data set, there are around 1801. So did you try for a smaller data set? Did you try for, yes,
Yes, ma'am. Yes,
yes.
ma'am. That
Did
I
you
am
try for
getting
smaller one?
right. Yes, ma'am.
You are getting right? So there is a
Yes.
possibility that maybe because the data, the array that you are getting is very high. One thing you can do is you convert this array into a CSV form of file you create, and just observe that whether there is in that file you are getting all of the rows as zero or not. Uh, Hello.
Yes,
Are you
ma'am.
getting my point?
Yes, ma'am.
So maybe right now in this particular screen it might not be visible. So maybe what you can do is convert this array into CSV file and then check whether most of the columns you are all of the columns you are getting zero as an answer. Then there might be a problem. Okay. Otherwise,
Okay, ma'am.
if you are getting properly for the smaller data set, then it is possible that you are getting properly for the larger one as well. So try for this. Okay.
Okay, ma'am. Thank you, ma'am.
Okay. Yes, there is a possibility. Yes, no, but in that case, what is happening is stop words would be removed already. We have in count vectorizer we have this attribute stop words. So stop words would be removed already. So that might not be the case. Okay, yes, wait, that might not be the case. Yes. Okay, Harsh. Okay. Yes, Harsh. So you are not. So the problem is solved, right, Harsh? Is it that is what you are stating through the statement? Hello. Okay. See, that's what I mentioned. That there is a possibility that since the array that you will be getting, so you may check the vocabulary size as well. Okay, you may check the vocabulary size as well. It might be of many columns in this case. So one thing you can try is convert this array into CSV form and check the CSV file once, that whether all the columns are getting zero, but it might not be the case. Maybe since the vocabulary is very high, so the array that is being shown to you is being shown as 000, because the array is of a very big size. Okay, if you'll check the size. So just try to experiment this, try to convert it into CSV and check once. but it might not be the case. You are not getting all of them as 0, but since it is being shown as such in, because it might not be able to print the entire array in the output. So that might be one of the reasons why you are getting 0 as an answer here. No, large number of values, I mean large number of vocabulary. The vocabulary is very high over here. In bag of words, what we are trying to do is we are creating vocabulary based on the sentences that we have in our data set. And then we are, for each of the statements that are present in our data set, we are creating vectors based on the vocabulary. For example, if we have 1800 set of vocabulary words in our data set, but our sentence might contain only 5 words, okay? So rest of all of the columns will be 0, only those 5 words will be containing 1 or 2 or 3 as a value. Are you getting the point? So that's why your array might be showing 0 maximum number of times, because the sentences might contain only 10 or 15 words in one sentence, but your vocabulary might contain a large number of set of words, right? Are you getting the point here? Yes, Harsh and Shainish? Okay. Okay, yes. Fine. All right. So I suppose all of you are clear with today's task. Yes, Keval, yes, you may unmute.
Yes, ma'am. I have a question like this. I am also getting 0. Then what is the solution you are telling, ma'am?
So solution, I'm not stating a solution, but what you might be a problem is maybe in the output it is not presenting the entire data set. That's why it is showing 0 as the maximum number of values. But in that case, the entire array might contain some of the statements, some of the words might contain 1 or 2 as a value. But just you want to observe. If you want to observe the entire array, what you can do is you convert the array into CSV file. And then you may observe in the CSV file that what are the places that you are getting 1 or 0 or 2, 3, 4 as a value. Are you getting the point?
Okay, ma'am. Ma'am, so I've got these vectors all are 0. Then can I go for the naive Bayes or any classifier?
Yes, you may go ahead with the classifier. This is just for your observation. You want to observe this entire array. That is one way that you may try this, right?
Okay.
Okay. Yes. So Juzer, a bag of word is done. Good. So what is the accuracy that you are getting for naive Bayes? Okay, Prince has a question. If that is the point. In 5 or 10 rows, the problem is for the small data set, it might show the array correctly, but for entire data set, it might not be showing you the array correctly. So one reason could be that. So try it once. Try to convert it into CSV file and check once that whether you are getting a maximum value, whether you are getting some other numerical values as well, right? Are you getting? Okay. Yes, Juzer, can you tell me what is the accuracy that you are getting for any one of the classifier that you might have implemented? So, which classifier did you implement? Okay, good. Okay, so you have just done the bag of words, fine. Okay, so Keval is getting 98% accuracy, fine. Try for this unigram bigram thing as well. Okay, 0.9. Good.
Hello, ma'am.
So, yes.
Ma'am, can I just present and verify that whether I have did correctly or not?
Yes. Yes. Share the screen.
Yes, ma'am. Ma'am, is it visible?
Yes, it is visible.
Yes, ma'am. What I have did, I have just take the features and target from the data set, then convert it into the divided into the training and testing. Then here I have performed this vectorization.
Okay.
And here I am getting all the 0. But when I perform this multinomial naive Bayesian, I am getting the accuracy like 98.6.
Okay, 98% you are getting. Yeah, that might be the case that I'm stating. That vocabulary is very high in this case.
Yes,
that is one point. Yes, your data set will contain a lot of vocabulary. That's why the data set that is being shown to you is containing maximum zeros, because one sentence might not contain that many words, right?
Okay.
So that might be one of the cases, right?
That means output is correct
Yes. Output is fine. Yes, right.
Okay.
And try for what you can do is try for experiment for some random sentences. Okay, experiment for some random sentence that you have, and try to check that what is the value that you make it.
Okay. That means, ma'am, you are saying that instead of passing this text and I should pass any random
No.
sentence.
No. In the after performing, after creating. Yes, Harsh. Just
Okay.
1 minute. After creating this classifier, so you already have this model. You have performed for testing test data set. You are getting the prediction.
Yes. Okay,
98%.
ma'am. For here.
Yes. Over here, you may pass any random sentence and just check. Okay, just for your testing.
Okay, ma'am.
Right.
Thank you.
Yes. Okay. Harsh. Yes. Please share.
Yes, ma'am. I have put this all the array elements into this verify.csv, and it is giving me this all as a result when I'm opening it. So means is it okay?
Okay, that is fine.
Yeah. So no, that only I wanted to verify.
Yes. Okay.
Okay, thank you.
You have done with other things, right?
No means
Okay. Yet to. Okay. Yet to. Do.
yeah,
Okay,
yes,
fine.
yet to done because I was also getting that 000.
Okay. See. Yes. Fine. Just observe that whether you are getting any other numerical values over here, right? Just checkpoints. Just go through the file, and later on, if you are still having doubt, you may email also in that case, right?
Yes.
Okay. Fine. You may stop screen sharing.
Yes,
So I'll end the meeting now, and if you are facing, I suppose that most of your doubts are cleared in this particular lab. And for those of you, I think some of you haven't uploaded the GitHub repository link as till now. Around 45 students haven't uploaded. So inform them as well that you have time till today to upload it in the evaluation one. And so I'll inform about the evaluation as well in the upcoming week. So I suppose today's lab is clear to everyone. If you still face any difficulty or any doubt, you may inform through the mail or in the lecture section also. You may just ask. Okay. So I'm ending the meeting now.